Okay, so in section 1.6, we're basically going to take a look at how we can create new kinds of functions from existing functions. Right, so what they'll often do is give you two functions and have you combine them in a certain way to create something new. Okay, some ways you can combine functions are using your basic operations you know. You could take two functions and add them, subtract, multiply, or divide. Okay, one other way to combine them, it's in the title of the section. Okay, we'll talk about it in a little bit. That's called composing, or composition of functions. Okay, and as we take functions and combine them, what we're also going to look at is the domain and ranges. All right, so when you have functions that are separate, okay, they might have a certain domain and a certain range, but once you combine them, you're messing around with the domains and ranges of them. Right, so we have to figure out how do those change as well. Okay, so that's what we're going to try to do. Right, so here's two functions, f of x and g of x. Okay. F of x equals x squared, and g of x, square root of x plus 1. One way I can combine these two functions to create something new is just add them together. They're not really like terms, so there's nothing I'm really going to be able to simplify, but that's it. This is a new function, x squared plus the square root of x plus 1. And it's a new function obtained just by adding two other functions together. That's it. Okay, another way I could combine them is to divide them. And if I combine them with division, that's the new function I get. It's x squared divided by the square root of x plus 1. Okay, there's more examples on page 58. Okay, when we combine functions, especially with division, we have to be careful. What do you have to be careful with when you have a fraction? Especially about the denominator. You've got to be careful with. Yeah, Ashley?
The square root.
Okay, square roots you have to be careful with too. So we got to be careful that we never take the square root of a negative. But what else about denominators in general? Even if there's no square root, they can never be what? Zero. Okay, so those are the things we have to watch out for. Okay, so how would we find the domain of one of these new functions? Okay, well, the domain of one of these new functions after combining two of them is all x values such that x belongs to the domain of both of the original functions. Okay. X has to be a value that not only works in the first function, it has to also work in the second function. And we got to make sure if we do introduce any division that we're never dividing by 0. It's going to add one thing here. So with division, make sure the denominator is never equal to 0. And with square roots, make sure what's under the root is positive. Sure. Okay, what's under the square root, that's called the radicand. So just make sure the radicand is positive. All right, so let's take a look at a couple and see if we can find the domain of the function. All right, so first thing I'm going to do before we even combine these functions together, let's just find the domain of each one separate. Okay, so we know at least what the domain is to start. Right, well, Madison, what values would I be allowed to plug into f of x? Yeah, anything that's greater than, did you say greater than or equal? Greater than. We could also plug in -3. That would be okay too. So square root of 0 is okay. You just can't go square root of a negative. Okay, so in this case, the domain is all x greater than or equal to -3. And Connor, how about g of x?
X not equal. I'll write down the definition still.
What are you trying to avoid under that square root? Trying to avoid what kind of numbers?
0.
0 is okay. You can take the square root of 0.
Negative numbers?
Negatives. Yep. So we have to make sure whatever you plug in for x that this never goes negative. So what kind of values for x would I have to pick?
I'm sorry, I'm having a mind blank here. I'm really tired.
You want to help them out? Yeah.
Greater than 2.
Greater than 2?
Or equal to.
Or equal, yeah. Okay, if you pick any number greater than or equal to 2, the radicand will always stay positive. Okay, so any question on the domain of the originals? All right. So now we're going to take the two functions and we're going to add them together. Okay, so f of x plus g of x, you can't really combine them. There's no way you can add these kind of square roots together. So you're just going to write it out. Square root of x plus 3 plus square root of x minus 2. Now I want to know the domain of that function. Okay, so if you go back to the definition, it says the domain of the new function is all x values that belong to both of the original domains. So you could almost think about like which one of these is more restrictive. X greater than or equal to -3 or x greater than or equal to 2. There's a lot of overlap here, but one of them is a little more restrictive than the other. X is greater than or equal to 2. That's your domain. If you pick a value like 0, you'd say, well, 0 is greater than -3. Yeah, that'll work fine in the first square root. But try plugging 0 into the second one. 0 minus 2 is -2. That won't work. All right, so you got to pick the domain so all the x values you pick work in both functions. Questions on that? Okay, another way to think about it is if you were to graph it, x is greater than or equal to -3, and graph what's below it. Look where they overlap. So here's a number line. Let's put 0, -3, 2. Okay, if you graph the top one, close circle on -3, shade everything to the right. If you graph the bottom one, be a closed circle on 2, shade everything to the right. What we're looking for is where these domains overlap. Okay? They overlap from 2 and up. Okay. Right, let's try this one. F of x divided by g of x. Right, Devin, could you tell me what, you don't have to give me the domain, just what's f of x divided by g of x?
The square root of x plus 3 over the square root of x plus 2, x minus 2.
X minus 2, good. Okay, so there's our function. Now I want the domain. Well, we already know where these domains overlap. x greater than or equal to 2. Right? So those, if you pick a value greater than or equal to 2, it'll work separately in the top. It would work separately in the bottom. But now think about this fraction. Yep?
It would just be x is greater than 2?
Yes. Can you explain why?
Because if it was 2 on the bottom, it would be 0.
Right. So greater than or equal to 2 would work separately in each one, but watch what happens if you plug 2 into the bottom. 2 minus 2 is 0. Square root of 0 is 0. That's fine. But then the fraction bar causes a problem. You'd be dividing by 0. So in this case, you've got to pick greater than 2. Any questions why it's greater than 2? All right. All right, let's try this one. So it's f of x divided by g of x. Okay, f of x is the absolute value of x. And g of x is x. What's the domain here? What values would you be allowed to plug into that fraction? Sometimes it's helpful to maybe think about what values you can't. Maybe that's sometimes an easier way to say it. Yeah.
Can't you plug in anything but 0?
Anything but 0. Okay, so the domain is all real numbers except 0. Now, if you look at each one separate, absolute value of x, you can take the absolute value of anything you want. What kind of numbers can you substitute in for a variable? Anything you want. It's the fraction bar that causes a problem. Okay? So the domain is all reals except 0. Okay. And the range. Let's think about it a little bit before we graph it. Let's say I plug 2 in for x. Oh, Bill, if I plug 2 in for x in the top, what do I get?
2.
2? If I plug 2 in for x in the bottom, what do I get?
2.
What's 2 divided by 2?
1.
1. Okay, so we know we get 1. Leon, if I plug 5 in for x in the top, what do I get?
5.
What about if I plug it in the bottom?
5.
What's 5 divided by 5?
1.
1. Okay? So pretty much any positive number that you plug in, the answer is 1 when you simplify it. Let's try a negative. Okay, see what happens there. Derek, what if I plug negative 3 in the top?
You would get just 3.
I'd get 3. What if I plug negative 3 in the bottom?
You'd get
What's positive 3 divided by negative 3?
negative.
Negative 1. Okay, and anytime you plug in a negative number, you're always going to get negative 1. Okay, so let's look at the range. The range is very limited here. It's basically 2 values. And that's it. So type in math, number, absolute value of x, use your arrow to get over there, divide by x. Just do zoom 6. Okay, so what you're looking at, anytime you plug in a negative value, the answer is always negative 1. Plug in a positive value, it's always positive 1. So the way you explain the range here is list every value in the range. Negative 1 and positive 1. Usually it's impossible to list every value that's in the domain or range. Okay, because there's infinitely many. Not in this case. Okay, questions on that one? Did anybody think it would look like that before we graphed it? Anybody have an idea? It's hard. A lot of times when you're first looking at some of these functions, you don't know what it's going to look like till you graph it. Okay, but we'll get better at that as we go. All right, so composition. Okay, composition is another way we can take 2 functions, combine them together to create something new. Okay, it's a little bit more complicated than just adding or subtracting. Okay, I'm going to show you how it works. Okay, if you understand the idea of substitution or plugging one thing into another, that's basically what composition is. It's plugging one function into the other function. Okay, let's start with these two. Okay, g of x is going to be the square root of x, and f of x is going to be x squared plus 3. Okay, and what we're going to find is this. Okay, the way you pronounce it is g of f of x. Okay, maybe even before we do that, let's start with something even simpler. What if I asked you to find g of 4? Okay, how would you do that? How would you find g of 4? What does that mean to do?
You put the 4 into the x.
Yeah, take what's inside the parentheses and fill that in for the variable in the function. So all you do is take what's inside the parentheses and fill that in for the letter in your function. We're going to do exactly the same thing here. Take what's inside the parentheses and fill that in for the letter in our function. Basically just like that. Okay, took what's inside parentheses, filled that in for the letter in my function. Okay, and Dominic, what is f of x? What does it actually equal?
X plus the square root of 3.
One more time.
X plus the square root of 3.
Not quite. Close. Yeah.
X squared plus 3.
Yes. X squared plus 3. Okay, when you have a sum, you cannot take the square root of a sum. If you had a product under here, like the square root of 4x squared, then you can take the square root. But try it. Try something like, try taking the square root of 9 plus 4. If you do it separate, you'd have 3 plus 2. If you do it together, you have 9 plus 4 is 13, and the square root of 13 is not 3 plus 2. Okay, so in this case, that's all you can do. Right? So this new function is what we call g of f of x. Right? So you're just taking one function and plugging it into another. Right? Let's try it the other way. F of g of x. Now we might be able to do something that you were thinking about earlier. Okay, anyone think they can tell me what that's going to look like? You don't have to simplify it. Just tell me what I'm going to plug in where. Yeah.
Square root of x squared plus 3.
Perfect. I'm going to take g of x and plug it into function f. So I'm going to take g of x, square root of x, and I'm going to plug that in for the variable in x squared plus 3. So all I did was change that to that. Okay, and Leon, what's going to happen there?
I don't know.
What happens when you have a square root of something squared?
It cancels out the square root.
It cancels out. So if you cancel that out, what would you be left with?
X plus 3.
Good, just x plus 3. Right, so sometimes when you do composition, some things cancel and simplify. Sometimes they don't. Questions on that idea? All right. So you might see this symbol in your book too. G, little small circle, and F. This is G composed with F. It's the same thing as G of f of x. I'm always going to use this notation on the right. Okay. Okay, so when we do a test or something, this is how I'll write it. But I just want you to be used to seeing that too. A small circle means composition. All right, so the domain. How do we find the domain when we do composition? All right, it's 2 steps. Okay, first thing you're going to do is look at the inside function. Okay, and find the domain of that. Okay, so that's what we start out with. We'll eliminate any values that do not appear in the domain of the inside function. Okay, what do I mean by inside function? I mean that one. Or in this case, that one. It's the one that's inside the parentheses. Okay, so eliminate any values that are not in the domain of the inside function. Okay, and the second step is we're going to take a look at the composed function we just created and see if there's any additional values we need to exclude. The only 2 reasons I can think of that we would have additional values to exclude is if somehow we created a fraction, we got to avoid dividing by 0, or we have some kind of square root. We don't want that to be negative. Okay, so remember, you got to be careful with fractions and roots. All right, so let's try example 3. So we have 2 functions, f of x and g of x. F of x is x plus 1. G of x is the square root of x. And the first thing they want us to do is just evaluate. Okay, just find the value f of g of 9. Okay, the way you do this, you start on the inside function, deal with that first. You're going to get a result, and then you're going to plug that result into the outer function. All right, so John, what's the first thing I'm going to do here?
I'm not sure.
So you're going to start with the inside function. And how would you figure out what that inside function is?
Then it's square root of x.
Yep, you're going to use the square root of x function. What would you plug into it?
The 9.
The 9. Okay, first thing you're going to do is find g of 9. Okay. So for now, you're not doing anything with function f. We're just going to find what you get when you plug 9 into function g. Okay, so that's all I did. Plug 9 into function g. And Madison, what do you get when you take square root of 9?
3.
Good, we get 3. Okay, so now we simplified g of 9. Okay, we got 3. Now we're going to find f of 3. Right, so Cameron, what would I get if I plug 3 into function f?
4.
Yeah, I get 4. Plug 3 in, get 3 plus 1, which gives me 4. Perfect. Any question on that? Now, do you think if I switch the order, if I did g of f of 9, do you think I'd get the same thing? I think no. Not necessarily. Okay, if you did, it's just a coincidence, but usually you won't. All right, now we're going to do the same thing again, except this time I'm going to do it with a variable. So Derek, can you tell me how I would find f of g of x.
You would just put in the square root of x into x in the f of x, so you would have square root of x plus 1.
Perfect. That's it. He took g of x, took that, and he filled it in, plugged it into function f. Right there. So this is square root of x plus 1. It's perfect. Okay, let's try switching it around. G of f of x. Okay, Katie, can you tell me what g of f of x would be?
It would be square root of x plus 1.
Yeah, square root of x plus 1. Like that? Yep. So this time, take f of x. That's your function. And you're substituting that into function g. Right there. Right, so you get the square root of x plus 1. Okay, any questions on that? Or is the idea of composition making a little bit of sense how you do it? It's what?
I find it fairly easy.
It's pretty easy. Yeah, so it just takes a little bit of getting used to plugging one thing into another, but it's just substitution. That's all it is. All right, let's try. I got a bunch of these. Okay, let's take these two functions and see if you can try those on your own. Find g of f of x and f of g of x. Same thing we just did. Okay, I also wrote it with the other notation. You can see the small circle, but you're doing the same thing we just did up above. All right, let's take a look at the first one. G of f of x. Okay, how about Jen? What did you get for g of f of x?
Except the square root of x squared minus 1.
Yeah, the square root of x squared minus 1. Right? So you're taking what you have for f of x and you're filling it in function g. Okay. There's function g. Right, it's the square root of, and now plug in f of x squared minus 1. Good. Okay, and the domain. Well, remember, with a composition of function, start with the inside function, f of x. Ashley, is there any restriction on the domain for f of x? No. No. You can take any number you want and square it. Okay, so that's step one. We're gonna right here. Eliminate any values that do not appear in the domain of the inside function. This time we're good. Now we're going to look at the composed function. Okay, Aiden, what do we know about this square root? What's underneath it's got to come out what? Yeah. What's underneath here has to come out positive. Okay, you want x squared minus 1 to be positive. Okay, so what I would do, try solving this. You want x squared to be greater than 1. What kind of values can you square? And the answer will always come out bigger than 1. There's a couple possibilities there. You think, Tommy?
Positive numbers?
Can you be more specific? Like 1/2 is a positive number, but if I square it, it's not bigger than 1.
Integers. Positive integers.
Okay, positive integers, yeah. So we could pick any number bigger than 1. Okay, and you could use things other than integers as well, like 1.5. That's okay. So any number bigger than 1, or what else?
Anything less than negative?
Or anything less than -1. Okay, if you square something like -2, that'll come out bigger than 1. And so your domain, you could say we want x to be greater than 1. And technically, you know what? It could be equal. That's okay. Because if it's equal to 1 exactly, you'd get 0 under the square root. That's okay. So x is greater than or equal to 1, or less than or equal to negative 1. Okay, any question on that one? Let's look at the graph. It's going to look a little different. Okay, in this part, if you want to graph it, you can, or just watch me. That's fine. Okay, but you're going to see a graph going in 2 directions, and it's going to cover all x values greater than 1 and less than negative 1, but nothing in between. Okay. And it almost looks like these are straight, but if you zoom in a little bit, you will see that they're curved. Okay, and let's try it the other way around. F of g of x. Okay, how about Autumn? What did you get for f of g of x?
Simplified or unsimplified?
Well, you can give me unsimplified first, just so we can see how you get your final.
Well, in parentheses, it was square root of x squared.
Yep.
Minus 1.
Minus 1. And then simplified, the square root and square cancel. We get x minus 1. Okay, now here is where you have to be careful. If you just looked at the final answer, you'd say there's no restriction. We've got to check and see if there's any values that were not in the domain of the inside function. G of x. Are there any values or any kind of restriction on g of x? Derek?
It can't be negative.
It can't be negative, so what does it have to be?
All
Non-negative, yeah, 0 or higher, okay? So 0 and all positives. So the domain here, from the inside function, x had to be greater than or equal to 0. And there's no additional restriction from the final function. There's no fraction, there's no root. And if you graph these two things on the calculator, they're not going to graph the same. Okay. Watch what happens if you graph the top one. Okay. Put in parentheses the square root of x. Let's try it like this. Okay. Square root of x squared minus 1. Okay, and then hit graph. Notice where the line starts. It starts at 0. Does it go in the other direction? No, because there's a restriction on the domain from the original function. Now, if you plug in the simplified one, x minus 1, it's going to shade the whole thing. Because now the calculator doesn't know that the square root of x was there originally and got canceled out. Okay? So you have to know that. So you always check the domain of the inside first, then check the final one. Okay, questions on that? All right. So if we can find the domain of a composition function, the range isn't really that much harder. Okay, the first step to finding the range is to find the domain. Okay, figure out what that is. And then determine, when you plug those values in for the domain, what kind of answers do you get out? Sometimes a graph is helpful to look at here as well. All right, so for this one, I'm going to help you guys out with finding f of g and g of f quickly. And then we'll do the domain and range. All right, so let me start with g of f of x. take function f, plug it into g. Function f is the square root of x, plug it into g. Okay, there's your function. Okay, domain. Check two things. Check the original, f of x, that's what's on the inside, and then check the final. There is a restriction on the domain for f of x. I have to pick values greater than or equal to 0. In my final function, there's another restriction. I have to pick values greater than or equal to 0. It's the same restriction. All right. So we don't gain any new restrictions here. Just make sure you pick x's greater than or equal to 0. And the range. Well, if you're not sure of the range, graph it. And look at how high and low the graph looks like it's going to go. So let's graph the square root of x minus 3. It's kind of hard to tell, but if you graphed it on yours, how low does it look like that blue line is going?
-3.
Yeah, it will go down to -3. In fact, if you plug in 0, you get the square root of 0 is 0. 0 take away 3 is -3. So the range is going to go from -3. And how high could this number go if x gets bigger and bigger and bigger? Yeah, infinite. Okay. As x gets bigger and bigger, you're just going to take the square root of something bigger and bigger and subtract 3. So it's going to go up forever. So your range is all values from -3 up forever. Okay, and then switching it around. Take g of x, plug it into f. So you're going to have the square root of x minus 3. Domain. How about Jean-Paul? Any restriction on the domain for function g?
No.
No? You can take any number you want and subtract 3. No restriction there. Now check the final. Devin, is there a restriction on this final function?
Yeah.
Absolutely.
Yeah,
Can't be negative. So what kind of values do you have to pick for x here?
x is greater than or equal to 3.
X is greater than or equal to 3. Good. Okay, and the range, let's graph it. So maybe you guys can kind of see this as a transformation. When you put a -3 on the end, it takes the square root function and shifts it down 3, just like a parabola yesterday. When you put the -3 on the inside, which direction do you think that's going to move it?
3 minutes to the right.
Yeah, it's going to shift it horizontally. In this case, what's after the minus sign? +3. Very good. So some of you probably don't even need to graph it. Okay, but the idea is now your range goes as low as 0 and up to infinity. So it's everything from 0 up. Any questions on finding the domain and range? Feel okay? Let's try one of these. These can be a little tricky because it's like you're working backwards. Okay, they're telling you what f of x is. They're telling you what the composition is going to come out to. They want you to find the function that would give you the composition. Okay, so before I gave you the top two and you found the bottom one. Now I'm giving you the bottom one and you're finding one of the top ones here. Okay, so what would g of x have to be? Think of what would you have to write here for a function so that when you plug x squared into it, you get the answer ax squared.
AX.
Yeah, it would be ax. Now you can always check it. Take your function f of x, plug it into function g. So that means change all your x's to x squareds, and you would get ax squared. That's it. Okay, it's a little weird to kind of work backwards like that, but it's very similar to what we were doing before. Okay. Any question on that one? Right? I'm never going to give you one that's that complicated, because it is a little hard to do. Okay, so it's kind of like a trial and error. All right. We already did this yesterday. Okay, anytime you change your x's to negative x's, that causes a reflection over the y-axis. So if you were to graph those two things, you would see that one of them would be a reflection of the other over the y-axis. Okay, we talked about that yesterday. So the next part, I'm just going to generalize all the transformations we learned yesterday. Even though we only learned them as they apply to a parabola, they actually work for any function. They work for a square root, as you just saw. Okay, you can use them on anything. So what I want you to do is just kind of get used to how do you recognize, say, what a vertical stretch is. Okay? Anytime that a function is being stretched vertically, you're going to multiply by a number in front. Okay? And it can be any number you want, any real number. Okay, if you have a function and you want to shift it up or down, that's when you do plus or minus when you add it on to the end. Okay, it can be anything. X squared plus 3 would shift up 3. Square root of x plus 3, shift up 3. Any function plus 3 is going to take it and shift it up 3. Okay, the horizontal shift, left or right, that's when you add or subtract a number inside parentheses. Okay, for shifting left, sometimes I think of it, what comes after the minus sign? Negative. Right, so if you see a plus in parentheses, that's going to shift left. If you see a minus, that's going to shift it right. If you put a negative in front of a function, that's going to flip it over the x-axis. If you put a negative inside the function, that's going to flip it over the y-axis. Okay, and you learned all of those yesterday. It's just now I'm kind of generalizing them, not just to a parabola. Okay, any questions on anything on that right-hand side? How to recognize a stretch, shrink, anything like that? Shifting? So here's a graph. We don't have a formula for it. All we have is a picture. And in this case, they're going to ask me to transform this graph. Does everybody have what's up above? All right, so let's see if we really understand what's up above. So we're taking this function, and you know what? Let's just to make it simpler, a little quicker. What is this plus 1 going to do to this function? You did a plus 1 inside parentheses. Aiden? Yeah, it's going to take that entire image and shift it left 1. And what about the minus 3? What happens when you subtract a number at the end of a function? Yep. Down 3. So all you're basically going to do is shift every point left 1, down 3. You don't have a formula, all you have is a picture. Left 1, down 3. Left 1, down 3. Left 1, down 3. And just connect them the way they were. Okay, so that's just practicing a transformation without a formula. Any questions on that one? Okay, you'll have one or two in the homework like that, and this will be our last one. All right. So in this problem, it's on. Let's see. It's in your book, and it's on page 64. Okay. It says you have a spherical balloon that's being blown up, and the radius is changing at 2 inches per second. So that's how big it's, that's how quickly it's being blown up. Just to simplify it, we'll assume that before we started blowing up the balloon, it had a radius of 0. Okay? Technically, that doesn't make sense, because if it had a radius of 0, it doesn't exist. Right? But it simplifies our problem. What I want to find is an algebraic representation for V of t. This is the volume of the balloon as a function of time. Okay? So since the balloon is constantly getting bigger and bigger, the volume is constantly changing. All right? So this is going to involve a couple things. It's going to involve volume of a sphere, okay, from geometry. Which, if you don't know that, I'll remind you what the formula is. And then after we have a formula to find the volume as a function of time, we'll use it to find the volume of the balloon after 5 seconds. All right, so first thing you need to know is volume of a sphere. Okay, does anybody remember what that is? Volume of a sphere? Yeah, it's 4/3 pi r cubed. Okay, so that's your volume of a sphere. Okay, we'll come back to that in a second. Okay, next thing I want is a formula for my radius. Let's call it r of t, my radius as a function of time. Can anyone give me a formula that I could plug into and it would tell me how big the radius is at any time? Yep, 2t. So after 3 seconds, 2 times 3, the radius would be 6. After 10 seconds, the radius would be 2 times 10, or 20. Now, what do you think I'm going to do to find my formula for v of t? We've kind of done this earlier today. Yep?
You plug the 2 or whatever the value is from the r of t into the radius.
Yes, we're going to plug in 2t. That's our formula for the radius. Plug that in for r. Anyone recognize this kind of idea? Composition? Taking one function, plugging it into another. Okay, that's all that really is. So in this case, the volume is 4/3 pi 2t cubed. Okay, and we can kind of clean that up a little bit. 2t cubed. How about, Bill? What's 2t cubed? What's 2t cubed? Or think of it as 2t times 2t times 2t. Start with your numbers. What's 2 times 2 times 2? 8. Yep, 8. And t times t times t.
3t. Or t.
Careful, that's adding up.
Yeah.
Yeah.
T cubed.
T cubed. is there anything else there that I could combine together? Well, Maddie, what do you think?
I was thinking 12/3.
Yep. Yeah, the 4/3 with the 8. We can definitely put those together. 4/3 times 8 would give me what as a fraction?
10 2/3.
Okay, and how'd you get that?
4 times 8 divided by
4 times 8 divided by 3, so you wrote it as a mixed number?
3.
Is that what you did? That's fine. Yeah, you know what? You don't even have to go that far. Just leave it as what you just said, 32 thirds. That's fine. So 8 times 4 is 32 thirds pi t cubed. So there's your V of t. It's the volume of a balloon as a function of time. Okay, and the last part says find the volume when the time is 5 seconds. So you just fill 5 in for t. Okay, so let's see, if we do that out, we're going to have 5 cubed is 125. Okay, times pi. Your pi button on the graphing calculator is second, and then it's the exponent button. Times 32. And divide by 3. I typed it in a little different order, but that's commutative property, that's all fine. Okay, so the volume is, let's just say 4,188.8. Okay, anything else I should put on that final answer? Yep. What is, yeah, some kind of label, definitely. It's a volume. So what would be the label in this problem?
Inches.
You on the right track?
Cubed.
Inches cubed, yeah. Okay, so that's section 1.6. Okay, basically I'm creating new functions. So the homework tonight, page 66. It's 1 through 3, 6, 8, 13 through 15, 22 to 25, and then 32, 40, 44, 57, 63. Okay, so we'll take a look at that tomorrow, and we'll start chapter 2 tomorrow as well. Okay, I will also be here for extra help after school tomorrow. If anybody needs to stop by.